So we're talking about functional programming and machine learning, and definitely, machine learning is math, and math is very functional. However, if you look at kind of how the world is, you guys need to, sit on the side. Okay, that's awesome. So, but if you look at kind of all the new tools, you see a huge adoption of Python, and you also see that even TensorFlow just recently announced that they are now going to support an imperative mode for TensorFlow in order to make it easier for their users to use the tool. So is function programming really the future of machine learning? I think that's a great question for a debate, and this is what we're going to have today. So we have two teams of 3 people each, and guys, since it's a Friday, 5 p.m., let's make it fun, and I'll let the teams introduce themselves. We have the team that is for Leah, Oscar, and Chris. Chris, you can say, and the team that against will go next. So guys, introduce yourself.
Hi, I'm Leah. I actually work at Salesorce Einstein on Vitaly's team. I've been working in Scala, solving machine learning problems for about 3 years there. Before that, I was at LinkedIn, and before that, I was doing computational neuroscience at Berkeley. Yeah.
I'm Chris McKinley. I'm a director of engineering at Tact. We're a small gamification company, about 80 people. We use mostly Haskell and do a lot of machine learning.
My name is Oscar Boykin. I work at Stripe. I work on the machine learning infrastructure team with several other Scala-type people. We do most of our machine learning infrastructure in virtually all the machine learning infrastructure in Scala. Before that, I worked at Twitter, where we did most of the data engineering, ultimately almost all of it, using Scala. So that's my background with it.
Okay, you can keep the mic, and the team that is going against, just guys, please, the team that is going against, they're doing for the sports, they're not really against, so please not, so please,
how do you know?
Not
how do you know that?
Anything, so let's.
Hi, so I'm Justin Coffey. I work for Criteo. We're an ad tech company. We follow you around the internet. We're not as bad as Google, though, so we're nice people, but that's what we do. I run the analytics infrastructure team there, so responsible for all the data pipelines, databases, all that good stuff. And we use quite a lot of what this guy did, Scaldane and all that good stuff. So, yep.
Hey guys, I'm Ajith Grewal. I'm EM here at Twitter. We work on recommendation systems. I've been here for about 5 years. I was an engineer when I started. We use a lot of Scala inside Twitter, as probably a lot of you know. A lot of the stuff that Oscar has built has helped us scale at the company. Before that, I was at Yahoo working on language processing systems and using a lot of Python. That's my background.
Cool. So my name is David Andrzejewski. I work at Sumo Logic. We're a cloud-based machine data analytics platform in a kind of Scala shop since 2010. I've been there since 2011. I work on the data engineering and machine learning side there. And prior to that, I was doing machine learning research at Lawrence Livermore Lab. And I also co-organize a machine learning meetup here in San Francisco.
Okay, guys, thank you. So please, first of all, give a round of applause, especially for the team that arguing against, for being good sports. So the way we will do it is we're going to have it in Oxford style, because otherwise it's going to be a little bit unfair. So actually, the team that's going to win is the team that will swing the most votes. So we'll have a vote now. And again, the proposition is functional programming is the future of ML. So please, if you're for, raise your hand. Okay, and we have here my lovely assistant Mayuk, who is going to use a very advanced technology of taking a picture and then manually count the hands. And if you are against the proposition, please raise your hands. Oh, wow. Well, the against guys, you have a lot of votes to swing. I don't know about you guys. By the way, everyone who didn't raise their hands at the beginning, please, we also will count your votes. So, if by the end of this, one team did a better job convincing you, so please vote for them. So let's start. We're going to start with a very short intro from each member. We'll do it kind of team by team. So who's going first on the 4 team? You guys will have... Awesome. So Leah, take it away.
All right. So... Let's see. I guess the argument that functional programming is the future of machine learning. So basically, if you think about what machine learning is, it's a lot of math applied to data. And if you look at sort of the proliferation of machine learning libraries out there, there are many of them. They're written in many different languages, but a lot of them, I would say, probably the majority of the ones that become really big these days end up having a Python interface. And so the question that I would ask is, why do they end up having a Python interface? And I would argue that it's because Python has a low barrier to entry. So basically, you don't have a build system to worry about. You don't have to learn how to deal with types. Basically, anyone can use it. It's sort of simple. It's the easy way to get things done and get started. And so with that argument of basically the reason that it's getting this interface is because people can use it off the shelf, I would argue that as machine learning evolves, as it becomes more standardized, it's actually going to move further away from, or the interface will move further away from programming and become basically GUI-based. So it will be drag and drop programming of machine learning. So it won't be written in Python. It will be written in something that is, optimized for doing machine learning. And I would argue that basically, if in that case, functional programming is the optimal solution. So if you think about a drag and drop GUI, basically what you want to define is what's going in and what's coming out. You don't want to worry about any sort of objects. That's basically the paradigm that best fits this model. And given that we will move further and further away from programming everything in Python, because data scientists don't really want to do Scala or other complex languages, basically, they also probably don't actually want to do Python. They'll want to use GUIs. And the backends for those GUIs will be functional programming. All right.
OK, awesome. Thank you, Leah. And I think, Justin, you're next.
So thanks, Leah, for stealing all of our good arguments for why functional programming is not the future of machine learning. So I would like to, so I'm going to try to channel my inner Steve Ballmer without embarrassing myself too much. So data scientists, data scientists, data scientists, right? So that's precisely the tact that I'd like to take, which is that indeed the target audience here is not us. We're the engineers building lots of systems. We're building type-safe data pipelines and all this good stuff that are feeding these industrial strength machine learning systems. But data scientists are the ones who are actually bringing the value out of that system. And indeed, you look at TensorFlow, you look at a lot of these things, and they seem to sort of compile down to config files, right, at the end. And this is the model representation, which is this static representation that can be then interpreted by various runtimes, right? So you have things like PyTorch interop with Caffe2, right? So you've got this relatively high-level language that has a low barrier of entry, thank you, that then is able to be executed on something that's not necessarily functional programming, right? And so the runtime of these things is going to get ever more optimized because we're dealing with more and more data. And so while we'd like to, insist that correctness is more important than performance, we know that, from the various presentations we saw today, that all of this functional correctness all results into, imperative programming underneath the covers. And so I think that, yes, type-safe data pipelines will continue to be built in functional paradigms, but you're going to go from these very high-level things, which might end up being GUIs, all the way down to really, really low-level systems programming that's highly optimized. And I'm not sure that functional programming has a long-term future there. So.
Awesome. Thank you, Justin. So arguing for the propositions, Chris.
Okay, I didn't really plan my statement out very much. Hope it doesn't ramble. without definitions of functional programming, machine learning, and future of, it's hard to say anything really definitive. But certainly if we define the future of to be increased market share, then I think we'd win. If we define functional programming to be, I don't know, Hadoop or Spark, then I think we've won already. But I don't know, in the interest of saying something like more introspective, it seems to me like data science is still pretty underdefined. It feels a little bit like front end used to be in the early aughts. And I used to do a lot of data science work, and I did most of it in scikit-learn and then Spark. And I'm much, much happier doing stuff in Haskell. I also don't think it would have been possible for a small startup to use Haskell like 7 years ago. But it's certainly possible now, and we're not the only company doing it. And I think you'll probably see more and more of that in the future, mainly because doing machine learning well is hard, especially doing it without a lot of technical debt. There's just a lot of incidental complexity that you have to control for. And in order to do that well, you need good abstractions. And one thing that FP provides in spades is really good abstractions.
Awesome. Ajith.
Hey, thanks, Justin, for starting that off. So, like Justin was saying, data scientists are the core driver behind a lot of the machine learning innovation that's going on in terms of like what are the problems that machine learning is solving more and more. So I've been using Scala for a while, and the strengths that Scala provides are the ability to have these abstractions and have like type safety across complex feature pipelines that you build, and the ability to change those features in a type-safe way across like a big code base, and have the compiler do a lot of the heavy lifting. And that has been the strength for Scala, and we've used that a lot. More and more in the future, what I've noticed is happening is that the feature generation itself is being pushed down into these deep learned models. So what you end up doing is your features are these numbers and these matrices that you just want to push into some deep learned model. And in that world, the data pipelines themselves are not that useful. And another point here is data pipelines are useful when you have if you have like a tight loop between user generated content and the user generated labels. But in many of these domains, like for example language processing, which my background is in, we have expert provided labels where the data sets are smaller. And the kinds of questions that come up in those data sets are not about type safety, but about, say, avoiding bias, avoiding some of the other issues that can creep up in such situations. And those are the real questions that I would argue that in the future of machine learning we need to solve. And in that case, having like a much more flexible environment in which you can articulate these models and iterate on those models is the one that is going to provide the most value to data scientists. In terms of productionizing, like Justin was mentioning, it's nowadays relatively easy to write code that build a model that dumps out a.
Okay, thank you, Ajith.
Thank you. I proved my point.
Yeah. So, Oscar.
So that was probably like 4 years ago. I had probably too much to drink. Definitely too much to drink at a Twitter end of the week thing, and I made a bet with one of my colleagues who was a little bit of an FP skeptic. It was too much money. I hope he has forgotten how much it is. That a functional programming language would be a top 10 programming language within 10 years. And at the time, it was like on the borderline. Sometimes I've stopped for a moment and said maybe that was crazy, but I'm absolutely sure of that now. I would zoom back out. I would take even a stronger case that functional programming is the future of programming in general. Are there programming languages that are getting less functional? I'm not aware of any. So I don't know if we want to talk about. No, Go is not getting less functional. It was a language made 7 years ago. It's going to get more functional. Java is getting more functional. Python is adding types in Python 3. Like the direction is very clear here. It's not like Haskell's like, wait a minute, slow down here, everybody. Let's put some more mutation into the picture. So the direction is very, very clear. I think we always already talked about I don't know what the terms are, but if you come down to are you doing functional programming? If you're writing Java and you're writing Hadoop, you're still doing functional programming. You're still doing MapReduce. Maybe you have to squint a little bit to see the right monad in play, but it's still functional programming and it's getting more functional. So I don't really think you can say very credibly that vector is not going to keep going. Now, are there rough edges? Absolutely. Everybody knows about it, but I don't think we have to restrict ourselves to fighting with a compiler to say you're doing functional programming. Chris, is it Chris? The Closure dude, he's not down with types at all, but he's very adamantly a functional programmer. Yeah, Richicki, yeah. He does look a little bit like Chris Wenzel, though, if you squint. So that's what I was thinking. So anyway, we can keep going, but I'm absolutely sure that this is the future.
Okay, awesome. Thank you, Oscar, for bringing in the passion. So, David, tough act to follow.
Yeah. Close it out. All right. So the question before us here is, will or is functional programming the future of machine learning? Not should it be, or would we like it to be, or something like this. And if you're looking at kind of who are the winners today? So right before this, Justin was fishing out what are the top programming languages of self-identified data scientists? Number 1, JavaScript. I think then, we go down the list and it was SQL, Python, maybe C, C#, yes. So, okay, these are where the people are. This is where the market share is. And, the growth in machine learning and data science is going to be this democratization of it. It's not going to be kind of in the nuts and bolts data engineering necessarily that a lot of folks are providing a ton of value doing, but it's going to be that domain experts who just want to get it done. They are, and if you look at what is kind of the winning trend today, if you talk to somebody who's just trying to get it done in some programming context, what do they love? Notebooks, Jupyter Notebook, things like this. Now, is this really a functional programming environment, or is it super mutable, hot mess of global variable of workspace? Right? This is what people love. This is the democratization. This is where it's going. And there might be some functional programming stuff happening way underneath in whatever stack we've got. But the 80-20, the future of, the bulk of the value, the business activity, the creation, what wins in the marketplace is going to be really, really fast, fast. We were joking about, how we think about this is fast and furious, quick hacks, iteration, getting experiments out, lean product development, everything like this by domain experts and people like that, not necessarily worrying about referential transparency or, making sure that their sum types are properly aligned to the business domain or things like this. They're going to hit enter, run the model, push it off again until they get something that works. And with some of these new deep learning advances, what you actually see, when you're talking to researchers, they'll be amazed. They'll say, actually, I supplied the wrong input. I had a bug in my code. My deep learning optimization was so good, it still worked. So, this is the future, is people, hacking on notebooks with deep learning models that paper over their mistakes. This is how we see things going out. So should it win? Who's to say? But will it win? I don't think so.
Okay, awesome. So thanks for the team for their opening statements. Let me just recap them very quickly. So the team arguing for kind of said that sorry, people are moving to Python not really because it's imperative. Sorry about that. Not because it's imperative, because it's simple. You don't see people flocking to, C or C++, right? So, and the future is probably even simpler. And, simple today, if you take SQL or Excel, usually means functional. Also, the team added that for ML, you need very good abstraction. Functional programming provides this abstraction. The future is kind of, getting this abstraction better and better, and hence, functional programming better. And then kind of Oscar capped it off that, functional programming is not just the future of machine learning, it's the future of everything. It's the future of self-driving cars, self-driving planes, and that everything will become functional programming. The team arguing against is kind of the statement that they made that machine learning really is about becoming more and more about optimization, fine-tuning, and this is where really it all boils down eventually to imperative. Another point that was made that kind of data scientists, simple environments and I guess imperative programs offer that, and I think David kind of caps it off with kind of the future is about growth. Growth is about democratization, and democratization is about getting things done easily. And really today, kind of the imperative paradigm owns that world. So anyone want to respond to any of the arguments that were made by the other team?
You'll probably respond.
You should guys respond, and then we'll open up to questions from the audience. So if you guys have...
I thought David made a pretty good point. It's hard to really refute that in any categorical fashion, but it does strike me as pretty pessimistic view of the future. I mean, there are examples of, programmers improving the way that they do things. Go-to statements used to be popular at some point, and now they're never used. I think industries do also consolidate. It used to be pretty easy to write JavaScript in any bullshit way you wanted to and throw something up on like a lamp stack and get paid, and now you can't do that. You need to know React. So I don't know, maybe the same thing will happen in data science.
Yeah, so I think the 4 team is what they're really trying to argue is that the entire world is going to end up being functional, sort of despite themselves, and can be dragged kicking and screaming into this monadic paradise. I don't see that, like that's not what I see. I don't know about you guys, but I certainly don't see that in my day-to-day activities, either interacting with our clients, so our analysts, try to explain to them, the value of immutability, and their eyes start glazing over within like 35 seconds, and they're just ready to go leave, right? And that's with analysts. I have the same conversations with engineers, right? And maybe I shouldn't say that, right? Don't come work for Criteo, Oscar, right? No, actually do come work for us. But I don't think that the.
It's seriously.
Is that the music playing already? Am I going on that long? Is it that boring? I like to thank my mother, my father. Anyway, so it's even difficult to explain to or to convince engineers who come from a object-oriented or more imperative world that no, you need to learn these functional paradigms because just thinking this way can help you reason better about your code and deliver something that's safer and more robust, despite the advances of despite MapReduce, despite
yeah, feel free to interrupt.
Possibly because of MapReduce. Okay.
I think it's we've already got the obviously correct position, and I feel a little bit bad about exploiting it, but Vitaly even threw us a bone that I didn't even hear us make. But I just want to isn't it already haven't we already run? I mean, Excel and SQL are already functional programming languages and already the #1 ones. Okay, so that's already that's the case. The second thing is I think you are all being very, very myopic. This industry changes a lot. it wasn't that long ago that it was absurd to imagine running a garbage collected language. Like, are you serious? You can't run that in a service, like in production. And now, like, basically no one, very few of us here are probably writing code that is not running with garbage collection. Like, if you look today and say, like, is it painful to do thing X or thing Y? Like, sure, it's going to be less painful in the future. It's not going to get harder. It always gets easier. So all these things are going to get better. And it's not that, like, are you serious that you tell me that your Java 8 people that you talk to are like, man, I'm really pissed about these like lambdas. Like, all of a sudden, they're all on board now. Like, that's pretty cool. They're going to put case classes in next. Like, these things are actually happening. Even Guido is like, all right, we're Python 3, we're going to put the types in. So, I mean, any one of these, you don't have to have the whole picture. I don't think we don't have to win to convince you that we have to write everything in Haskell. We just have to say that some notion of the future of programming, and it's a big tent of all these ideas, is like more the future. And I think it's a really high barrier. You either have to say we're going to stop advancing at all, which it kind of what sounds like you're saying, which sounds really weird to me. I don't really see how computers stop advancing really soon. Or some other paradigm kind of wins, but I just where show me that. Show me.
Is there any audience questions while you guys prepare? I think someone is about to troll Oscar.
I won't troll Oscar. Is Spark's data frame API an argument for or against functional programming?
Oscar?
Look, I don't want to monopolize it. Look, there is I don't want to be an ostrich up here. Like, there are challenges to writing performant, in some cases, functional code. And Spark does have like a market pressure to write to minimize the costs. And they chose to do that by a certain API. They could have taken other choices. They could have done much of what they've done with macros or compiler plugins to get the same kind of semantic understanding of the code that they chose to do in that API. But instead, they went with the implementation that they did. And I'm sure they had a lot of good reasons for it. But, that's like one implementation. So I think that along the way, I mean, like, let's not forget that like Spark got where it got, running on Scala, using lambdas, using types. They were able to distribute the computation. They were able to give people a model to formulate the code. It's not like you write a while loop that like updates a bunch of mutable variables and someone has a magic wand to put on it and it runs on 1,000 computers. So that mindset of like distributed functional programming was what allowed us to scale to programming thousands of, like, I'm an old man now. I'm old enough to remember when it was a research problem of how could you ever program 1,000 computers. And now it's like, you don't really think about that. Now we feel like we know how we do it. And we only know how to do it because of functional programming.
Anyone else? So while
raise your hand.
There's here in the front. So here in the front. So Sasha, hold your thought for a second. I want to ask, and again, probably Oscar will monopolize this answer as well. But I want to kind of help, kind of the fellows here on the. I feel you were born, and you guys are not. But Oscar, you're saying like, people are not writing well, but if you look at PyTorch, if you look at TensorFlow, that's exactly what they introduced. That their big announcement was that, oh my God, now you can do for loops. Like, you don't have to like think in crazy DAGs anymore. So what do you guys think about that?
Well, returning to the previous point, I mean, if you use frameless, then data frames are pretty functional.
Come on, I'll get in on this. This isn't that hard. Like, progress doesn't, sadly, progress comes in fits and starts. So it's not like we are monotonically marching to a strictly ever more functional world. That's not what we're saying. And there are plenty of programmers who have not yet enjoyed the bliss of like the functional nirvana, but they will get there. That's right. So there are still going to be. I'm not saying that tomorrow we're going to turn it off, or there's never going to be another mutated variable. But I think that I mean I'm just going to repeat that the arrow is pretty clear, and I don't really feel like it's. I mean, Scala is increasing in adoption. Scala is like not decreasing in adoption. Haskell even is increasing in adoption. Languages are adding functional features. Like, tell me a language that removed one.
So the point that you're making is that languages are getting more functional, whereas for machine learning, it's more about what are the functional capabilities that data scientists are using. And the fact still remains that data scientists are not gonna, or there is no incentive for them to learn about functional programming to solve the tasks that they need to. All the innovation in terms of what are the machine learning models, what are the different modeling techniques, today are about the architecture of the models and pushing things down into the model, and not about hey, let's use this monad or these other functional programming features, like get rid of immutability and so on. So that's not the place where machine learning is.
So sorry.
Go ahead. No, go.
So I would argue basically that there is something of a distinction between a lot of what is data science and what is like machine learning for production. Right, so that hot mess of Jupyter notebooks does not get shipped to production, right? Like that has to be translated into something else. And so if you are going to actually put something in production, you need something that you can trust end to end, that will throw the right errors, right? And that ends up being in a more functional environment. So I would say that basically the future is data scientists will in fact want to have their actual model shipped to production. And so the thing that will happen is that the tools to build those models will become closer to what they need to be to have their model in production, which means that the underlying tools become more functional and less a hot mess of variables that change.
So I think that something that we need to quantify, which we can't, so it's helpful, is what percentage of data science is actually going into production, right? Do you need to get value for something to have value? Does it need to be a long-running service, right? And I would argue that there's a lot of business insight, which is going to drive what production will be, right? Is sort of post facto analysis, point in time analysis, which is now data science driven, and not just old school time series. And these sorts of things have a perfect life cycle in a notebook, right? And what is a notebook? But it's a way for this sort of so this sort of analysis, right? It's this hot mess. It's this interactive, it's like print line debugging or whatever. And in terms of, you build a little data set, you get a shape of it, and you iterate until you get to something, and then you stop and you say, that's my something, and there it is. And the work is over, right?
By the way,
for that cycle.
That is cool. That's great.
So
there's
Oscar,
nothing.
hold your thought.
There's nothing. I really want to address this. There's nothing non-functional about that. What is non-functional about a notebook? You have a bunch of let bindings. What is even mutable about it? The past already happened on the part of the page.
You can go back and change it. You can go back and change the cell.
You can. What? That's not functional programming.
Everything's
okay.
So FRP is not functional programming.
So finally, Oscar is lost for words. You want to?
No, but I mean, I feel like there's a little bit of a sleight of hand going on. That like it's kind of like I think you could translate all your arguments and say, data scientists are not going to be interested in subclassing to get their job done. Like subclassing is like not really what they need to be doing. Or like writing classes is a little weird. They don't really need to be doing that. Those are things that you kind of presume that there's a background knowledge that they already knew, and they could just write. They're going to write classes in Python, but like somehow that came for free. But like new people have to be taught, and they can be taught different things. And I think that these different ways that we're all using, like we're all old folks. To us, like we're still stumbling on these like new concepts.
Well, okay, guys, let's give the audience maybe divert a little bit.
Yeah. So my question is this: so don't you kind of feel a little bit of a deja vu here? So like if we were to rewind like 15 years back or 20 years back, and people would be saying, hey, listen, the world needs faster rule-based systems, right? Is it that you're telling me that this machine is going to tell me where I drive my car or something like that? And you're talking about this, the convexity and existence of solution and this gradient descent. What are you talking about? Like, all we need is faster, better rule-based system, and there's even Prolog in the Windows operating system. So let's just go this direction and don't talk about this, high-level stuff. Just like you said, referential integrity and all these things, it's kind of too complicated for people to understand. So it kind of feels like a deja vu.
So, sorry, which team is the question for?
Probably the against team.
The against team.
The 4 team will inevitably.
Like that?
So I want to roll the question back a second. We'll keep that transaction open, and I'd like to address Oscar here. So Oscar's argument appears to be that, no, seriously, everything's functional. Oh my God! Like just because a SQL query looks a lot like a monad, so SQL's functional. Well, there's no recursion in SQL, so to my knowledge, right? So there's some aspects of things that appear to be functional, and this goes back to Oscar's perspective that we are going to make everybody functional despite themselves, and I think that's the sleight of hand that Oscar is referring to. So. Regarding prologue, I think maybe I'll pass the...
Not a prologue, but a referential. Whether we basically experience a deja vu moment where we're saying, oh my God, it's like all goes back, but we're for. Is that a fair summarization?
It might be that it feels like it's a deja vu moment, and there is the rule-based system. So the analogy that you're trying to draw is that we are arguing over whether deep learning is going to take over the world, and that's the new rule-based system that's going to do everything. Is that the analogy? It's I guess for. I don't have a strong argument against that. Like it does seem like deep learning. There's like a lot of iteration on like what the deep learning systems are capable of. Unfortunately I don't have the background to help answer some of that.
Yeah, I just want to kind of take it down a notch here and get to governing dynamics. So for the 4 team, like what are the governing dynamics, what is the value add for functional programming that's going to inevitably cause it to take over machine learning as a discipline? And then for the against team, what are the governing dynamics? Like, what is it about functional programming that is going to prevent it from taking over the machine learning world?
Yeah. So this partially what we can look at today is like what is hindering, pure functional programming approach today for this like data scientist who is, playing around with their notebook. And I would say I want to add contra Leah's assertion. I'm sure the fine folks at Salesorce Einstein are not going to ship their Python notebooks to production.
Definitely not.
But I think in this democratization world, I'm sure it has happened. I'm sure it is happening. I'm sure. This is, the future explosion of machine learning is going to be, it's going to happen. It's already happening, I'm sure. So why do they want to not necessarily define super well thought out, referentially transparent functions and kind of compose their blocks out of this, when instead they can just say, hey, everything is in my notebook namespace because I'm just throwing a whole bunch of statements and variable bindings and assertions onto my notebook. I guess if I pretend the entire notebook is one gigantic lambda expression or something, I can sort of squint and say, this is a pure functional notebook. Within the world, I'm in that, it's like being in the ST monad or something. I never leave the notebook, and whatever I do in here, anything goes. But it's really not, it's that it doesn't have that property. And this, why maybe you would not do this is, if I'm writing a quick little helper function or something, I don't want to think about what are the inputs and what are the outputs or what's going on in this notebook. I just say, okay, I have this pile of garbage and I want a different pile of garbage with a table and a regression model on top of it or something like this. And I don't want to think about the inputs. I don't want to think about the outputs. I don't want sum types. I don't want product types. I want a thing at the end that I can push to production right from my IPython notebook, which I'm sure, again, there's probably a startup that's helped, that's probably their tagline. Push your Python notebook to production. And, so this, I just want to get it done. If it isn't, I'll run out the door right now. So, anything that gets in the way of me getting this done And maybe my future self, if I'm some data engineer building principled pipelines and I'm on call for this system and this, that, and the other thing, my future self will wish I had thought a little bit harder and refactored this into a proper pure function that I can reason about and compose. But the dynamics, this marketplace, it's worse is better. Like get it out there and iterate fast and win-win. These pressures are going to be pushing for, if I can get some advantage now and pay later, that's going to win out in a shocking number of use cases. And that's my assertion about the fundamental dynamics and why they maybe don't favor
the four team for governing dynamics.
So, yeah, I thank you for that clarifying question. So I think I would summarize their argument as like, it's all a pile of trash and everybody's really bad and like, that's just going to be the way it is and there's nothing anyone could ever do. And our argument is that technology tends to get better. Programming, like computer science technology, tends to get better. I think that if you don't want to think about the inputs or outputs to your function, I've got bad news for you. Like even non-functional programs have to think about inputs and outputs to their functions. So I feel like it's, yeah, you can write trash functional programming too. Like I've seen plenty of it. Like don't worry, there'll be plenty of opportunities for them. So I agree, if you have to struggle with everything, it will be a problem. I think our argument is that it will, as things develop, it will be less and less of a struggle. And so, just like manual memory management used to be a problem, it's not a problem anymore. You won't really, it's kind of a weird thing to say, aren't you worried about all that memory? Usually people are not. I think your statement of, how will I make this pure function? You'll just be like, I don't even know what that means exactly because I'm just making a function. So like a good language that works, I'm not saying it's going to be one that we have in our hands, but all of the ones are moving in that direction. And it will be easy, and there will be tire fires, and we'll have them functional tire fires, and it'll be great.
So I just want to push back one bit on, that this is a pessimistic view. There's some dramatization for effect going on here, no doubt, on our side. But, there might be, I could sort of make another controversial claim that in some of these applications, it might be the case that quality in some of these software engineering kind of sense may be overrated. If you're exploring the space of ideas really quickly and you're delivering some value, people are not, to say why do people put up with some of these things today, or why do they make one choice or another, they may be, their objective function for what they're trying to ship is different. And they might be very rationally trading off short-term gain for perhaps longer-term pain. And that might be a faster way to kind of explore the space of ideas and deliver some business value and find some new sort of problems that can be solved with these machine learning and data science techniques. And on some level, that's like part of the hypothesis of this democratization of the technology, right? Is that, it's not necessarily, it might be a little messy and it might be a little improvised, but somebody who knows something that somebody who knows a lot about functional programming might not know a lot about the domain. And, it might not be a perfect, crafted functional programming approach, but they know a lot about the domain and they get something super useful and valuable out there. We can kind of look at it and say, oh, this IPython notebook is a tire fire. But, if it's doing something useful and finding something and kind of moving the ball forward from a business or end user value, we can kind of pave over, forgive some of these other quality, quote unquote, software quality issues. And so it's not necessarily pessimistic. I mean, there could be a ton of really cool and innovative applications that people will get to by iterating super fast.
Yeah, but that's not machine learning.
We have a...
Yeah, that's not machine learning.
Can I just add one thing?
That's just like messing around. I mean, if you're talking about driving economic value, you can't do that in an IPython notebook. Like the news feed's not driven by an IPython notebook.
I mean, we have that concretely at my place of work. We have business value being brought by people doing stuff in notebooks, in an ad hoc way, right?
But that's like analytics. I mean, analytics have been around forever.
No, they're spinning up whatever TensorFlow in the background and the whole 9 yards. I think that so while we're trafficking in polemics and false dichotomies, I'd like to go back to David's startup idea called push your Python notebook to production.io. the idea that you have two startups on the table. One is push your Python notebook to production.io, and the other one is convince your data scientists to understand monads.org or something. I'm investing in the push your notebooks to production business model, right? Because okay, exaggeration for effect, but the point is that there is business value in that stuff, and the people deciding where to spend money, they're looking at where they get the most value, the most quickly from.
So I would argue that's true. There's business value from it, right? But there's also a cost to mistakes in it. And so if you have tools that have better guardrails against mistakes, like passing the wrong data type into your function, then those have a serious benefit and will convince people to use it, because it actually costs money if you're making business decisions off this like hot mess. If you can avoid mistakes by having a easier, more guardrails basically on your system, then that's really worth adopting.
Yeah,
right?
so I totally agree with you. I think that's a great point. And I'd like to bring human nature into this discussion. Path of least resistance, short-term value optimization versus long-term value. Let's take a look at banking regulation, stock market, CEO pay, stock options, and the whole 9 yards, right? I mean, human nature is to optimize for short-term value and not long-term value. That's what we do, right? And
I think you're making an argument that there will never be a better DSL for any kind of machine learning than an IPython notebook, which seems untenable in the face of like all economic rationality.
Yeah, I feel like you're begging the question. You're saying because it's impossible for it to be usable, therefore, because it's impossible to be usable, no one's going to want to use it. It'll be too expensive to use. But we're trying to discuss, like, our position is that it will be much more usable in the future. So just to reiterate that, I think you keep saying these things as though it's like an absolute statement of fact that, like, you've got to understand monads. Like, you don't have to understand GC algorithms to use Python. You don't have to know it's even referentially counted, like reference counted. It just fades into the background because it just kind of works for you. We're arguing not that you're going to be a category theorist in order to do machine learning. We're arguing that these tools will make it very easy for you to do functional programming like you're doing when you're using Excel.
So we have a last question, but let's say in the meantime, everyone who's not answering the question will have a round of closing statements. You guys will each have 2 minutes. I think Oscar will need 10, but you will still have 2 minutes to just close your statement. So let's take last question.
Cool. So I thought the question about governing principles was really good. And to play devil's advocate as well and like narrow the scope, because talking about machine learning is a huge field. Let's imagine something like logistic regression in particular. Basically, the idea is that you have some weights. You want to learn those weights. That's some state. Describing that through iteration feels very natural. So I think that does kind of beg the question of what does functional programming add in that context? And so that's my question. To try and make, because I do kind of agree that this has been an argument of like there's trash and maybe we can shine it into gold. I think there are other arguments to be made as well.
So for team, do you want to take it?
Sure. Well, FP has always been backed by imperative code at some level. A computer is an imperative machine. And no one actually codes up logistic regression anymore. You just use it like a function. So it seems like a little bit of a category bending question to say, will people use like a state monad to run the like gradient descent loop that optimizes logistic regression? Yeah, I guess you could do that, but I don't think that's what we're arguing. We're arguing for more restrictive tools in spaces where mistakes are very, very costly. Okay, awesome. So we're now on the final round, and let's switch gears a little bit. The team that is against the proposition, you guys, whoever wants to first start with your closing statements. A little bit of advice. It will make it very powerful if you end your statement with, and this is why you need to vote for our proposition. Or against, yes.
So I can start. I think you should vote against functional programming being the future of machine learning, because a lot of the arguments that have been made are everything is going to be functional programming, and while maybe the underlying tools, you can make the argument that hey, they can be functional programmed. The work that's being done in machine learning is going to be on the data science side, and a lot of the stuff that data scientists use, the programming techniques that they will use, data scientists today are more comfortable with a non-functional programming approach, and I don't see a case for why that would change in the future. That's my argument.
Okay, thank you, Ajith. Leah?
So the reason I would argue that functional programming is the future of machine learning is that basically functional programming provides better safeguards against very costly mistakes in developing systems that, even if they're not shipped to production, provide real monetary cost to a business that is trying to use machine learning in order to make decisions. If they are shipped to production, then of course it's hugely important that these things run reliably. And so as tools improve, they will tend to take on more of the characteristics of functional programming. And the data scientists will simply use the better tools without understanding that that is what's happening to their tools. And so that is why functional programming is the future of machine learning. Awesome.
Who's going next on the against team?
Yeah, so Justin? I think Ajith said it best. Sort of, if you accept, in some senses, if you accept that functional programming is going to take over every single domain of programming, then by definition, right, machine learning is going to be functional, right, or the engineering around machine learning, as Leah put it, is going to be functional. I put forward that while I think that there is a strong core of functional programmers, all of us folks here, and that there are inroads in terms of functional paradigms making it into things like JavaScript, which I think to a lot of people even 5 years ago would have been like what, right? The fact is that it's still a huge minority share of what's going on in the big wide world, right? Whether people know it or not, I think is actually important, right? That's a semantic that's important, because if you're mindlessly doing something, right, how are you actually taking advantage of what's happening? You have to understand, you can't just plug A into B and hope to get C reliably if once these things are put to the test and deployed and under load, you have to understand the internals. You have to understand what's going on, right? And so I don't think that the functional paradigm is necessarily going to win the day of every single system that's being deployed into production. And so I don't think it's at all clear that machine learning, which is sort of inherently iterative and imperative, is going to, and especially with the advances in sort of deep learning, obviating the need for some amount of fancy feature engineering and all this other stuff, it's not at all clear to me that
thank you, Justin,
that will happen.
So now closing for Chris.
Sure. I think you just proved our point. If you look at like the long arc of history, I don't know. It's easy to get confused about things, and if you take a historical viewpoint, it's pretty clear that things get more functional. Like 15 years ago, the main way that you parallelized code was like you use OpenMP or MPI and painstakingly with a dedicated data center that you pay IBM for parallelize code. And the idea that you would use like a concept or a pair of concepts like map and reduce to cheaply deploy parallel jobs on commodity hardware, people would have on a panel like this totally laughed at it. But now, not only did that happen like in one company, but then every single company had to do it just to compete. And competition's real. And if there's a better way to do something, it will eventually get adopted if it really is that much better. And I can't imagine a conference like this or a panel like this 10 years ago. It seems unlikely. It's even sort of unlikely now, but I don't know. Having been here the last couple of days, I've seen nothing but talks about DSLs and better ways of doing machine learning. Like Oscar just gave a talk about, using functional reactive programming paradigms to do feature engineering to solve a complex problem with like test training slip or feature slip. And that's a real problem. Like if your features are joined in a way that's not time sensitive, that can cause data leakage in a model or test training skew in a model, and it costs you a lot of money. So if that's actually a real advantage in the market, it's going to be adopted. Like I'm going to go back to my company and take all my FRP engineers off of Reflex and start doing it in Haskell. And then, if that helps us, then maybe other people will do it too.
Yeah, awesome. Thank you, Chris and David.
Engineering is all about trade-offs. And it's definitely wider than just the purely technical ones. And for us to say, okay, incrementally things gradually getting more and more functional, given the sort of assertions of like overwhelming superiority of this family of techniques, you have to ask the question of why hasn't it already won? And there must be some reason, some kind of governing dynamics that are sort of pushing back against this. And part of it is this implicit, if we define functional programming as, okay, referential transparency. And this is the big pure functions. These are the big kahuna. These are the big pieces, right? In some sense, the bargain here is that you are giving up some flexibility in the kind of functions or the kind of code you can write to win all of these other benefits that we don't need to belabor here. But there is a trade-off. I can't kind of arbitrarily do whatever I want in some random function and reach into every variable and have these globals and do all this other stuff. So, of course, there might be very good reasons for not doing this, but just saying that better tooling or better technology or GC is going to kind of eliminate this trade-off where I lose ultimate flexibility to make horrific mistakes, but I gain all of this reliability and all this good stuff. That I don't see the logic or necessarily the reasoning here that's going to sell that. And the question then you have to ask is these trade-offs of losing the flexibility now in order to gain the reliability and clarity and composability benefits later in the democratized world of productionizing your Jupyter Notebook and things like this, is that the trade-off that people are going to pursue? Or are they going to say, no, I want the ultimate flexibility and I'm not really going to worry that much about the later consequences. And this, these kind of governing dynamics of iterating fast and not having to, necessarily think about how I want my code to be factored out or my data types to be defined and things like this. These are the concerns of kind of a next level, and I don't think we have it.
Thank you, David.
Vote no.
Okay, and last but not least, Oscar. Ladies and gentlemen, call your significant others, tell them you will be late. So, Oscar, the stage is yours.
Yeah, I'm going to agree with my colleagues here that I think you have to vote for us unless you feel that the future is like one of like stagnation. This side says we can't make better tools. This side says today data scientists like to use Python this morning, and I think Ajith said, and I don't see that changing right now. But our debate is about the future, and we're not arguing whether you don't have to agree with us that like today people like Python. You have to vote for us. They like Python today. What we say is that it's going to get easier. You're going to stop writing your logistic regression. You're going to call a pure function, takes some data, and spits out the model. And that's a perfectly nice pure function. If you believe that's going to happen, vote for us. If you believe deep learning is going to be a black box behind which you will throw, again, here's some data and out will pop a model, vote for us. If you believe a model where I throw data at it and it out pops a prediction is a pure function, vote for us.
Okay, awesome. Thank you. Everyone, please give a huge round of applause for our wonderful debaters. Okay. So now, in order to determine one, the system will be that is the team that was able to sway the most votes. So since the team arguing against the proposition did not have too many votes going for it at the beginning, let's again vote who is against the proposition that functional programming is the future of ML. Please raise your hands. Okay, awesome. So it looks fairly similar. And who is now for the proposition that functional programming is the future of ML? Okay, ladies and gentlemen, I think we have a winner here. The team arguing for the proposition. Round of applause.